Mysteries of our galaxy, discoveries that shock science, and mysteries not yet solved. In this video, we will explore some of the most fascinating discoveries about galaxies and our solar system. We will answer questions such as how do galaxies form, and is our solar system unique? We will also delve into the mystery of what is the universe made of, and discuss dark matter and dark energy, which remain some of the biggest enigmas of our time. How do galaxies form? The simple answer is through gravity. Primordial matter in the newborn universe wasn't spread out evenly. Areas of slighter, greater density attracted more matter and grew bigger over time. Empty spaces grew emptier. Thus, even though the universe was expanding, matter was pulled into lumps that eventually grew into galaxies like our own Milky Way. Cosmologists studied the birth of galaxies in an expanding universe by running huge computer simulations, like the giant Millennium Run performed by Durham University scientists. That's right, astronomers can build a universe in a computer. The statistics of the resulting galaxy distribution are then compared to the observed large-scale structure of the universe. The good news is that one particular model agrees very well with the real thing, a universe in which most of the matter consists of dark particles that hardly interact with normal atoms. According to this model, galaxies and clusters of galaxies should be interconnected by filamentary structures, and some observations seem to support this view. However, there's a catch. The models also predict that big galaxies are surrounded by hundreds of smaller ones, and those are not observed. Also, it's unclear how the first massive galaxies could form so early after the Big Bang. So the current picture may be incomplete after all. Is our solar system unique? It's fascinating that this question can be asked at all. Until the mid-1990s, astronomers didn't have a clue about the existence of other solar systems. True, a handful of sterilized planets had been discovered orbiting pulsars, compact stellar corpses that emit copious lethal X-rays, but no one knew about planetary companions of sun-like stars. So has the question about the uniqueness of our solar system been solved? In a way, yes, we now know that it is not the only one. Astronomers now know of other sun-like stars that are accompanied by one or more planets. Exoplanet hunters have encountered many strange exoplanets, including hot Jupiters that apparently spiraled inward into small and fast orbits, knocking other planets into highly elongated paths during the process, or kicking them out of the system altogether. A small, Earth-like world in such a system would probably not survive this game of planetary billiards. Thus, planets that are hospitable to life may well be less common than some people had imagined. On the other hand, current telescopes are unable to detect a solar system like our own, although future ones should be able to do just that. So in fact they may be pretty numerous. After all, nature never makes only one copy of anything. Our solar system may be rare, but it's probably not unique. However, we won't know the answer to this question for sure until a similar solar system is found. Is there life beyond Earth? No matter how improbable the origin of life on Earth may have been, there should, theoretically, be many other living planets in the universe. The argument goes like this: there are about 100 billion galaxies in the observable universe, each containing tens of billions of stars. Many of these stars have planets, so even if life only forms on one planet out of every trillion, the number of life-bearing planets in the universe is in the order of 1 billion. Of course, the tantalizing question of whether or not there's life beyond Earth will only be answered if and when we find it. In our own solar system, a few locations appear to be hospitable to microbial life: the planet Mars, the subsurface ocean of Europa, one of Jupiter's Galilean moons, and maybe the warm interior of Saturn's satellite Enceladus. The discovery of Martian bacteria, either extant or extinct, would immediately tell astrobiologists that life is extremely common in the universe. So far, however, nothing has been found, although there's plenty of evidence that Mars was warmer and wetter in its distant past. Casting their nets a bit wider, astronomers are just starting to sniff out the atmospheres of exoplanets. If a planet's atmosphere turns out to contain substantial quantities of oxygen and methane, it's almost certain it must have living organisms on its surface. On Earth, it took billions of years for life to evolve from single-cellular organisms to anything bigger than the full stop at the end of this sentence. Looking for microbial life may therefore give us the best chance of success. On the other hand, that restricts the search to planetary systems in our immediate neighborhood. That's why some researchers are trying to eavesdrop on the radio communications of alien civilizations. If they exist, they could be picked up from the other side of the Milky Way. However, this search for extraterrestrial intelligence SETI assumes that the biological evolution of life necessarily leads to intelligence and technology. Ask an evolutionary biologist and they might well laugh in your face, because evolution has no built-in goals. Moreover, as Italian physicist Enrico Fermi once remarked, here are they. This is known as the Fermi paradox. If alien civilizations are so abundant, it should have found and visited us long ago. For now, no matter how likely the existence of extraterrestrial life seems, is still an unproven hypothesis. And that probably won't change anytime soon. It's a funny question too, because there's no way to disprove the idea. As long as nothing has been found, some people will always believe they haven't looked hard enough. What is the universe made of? The short answer is very simple: no one knows. The familiar matter that we do know about atoms and molecules is just the tip of an enormous iceberg. By far the largest amount of matter is dark and consists of unknown particles. If that wasn't mysterious enough, the vacuum of empty space is filled with a mysterious dark energy that accelerates the expansion of the universe. We're not only blind to the bulk of the iceberg, we also fail to understand the dark ocean in which it floats. Dark matter reveals its presence by its gravitational influence. This can be seen in observations of the rotational velocities of galaxies, the motions of those galaxies in giant clusters, and the way the gravity of the clusters bends the light from background objects observed during gravitational lensing. All suggest that the total amount of matter in the universe is about 30 times more than what can be seen with telescopes. So could dark matter be accounted for by dim stars, cold gas clouds, and black holes? Unfortunately not. If all the dark matter were composed of baryons, protons, and neutrons that make up atomic nuclei, the universe would look pretty different. With so many baryons around, the nuclear fusion reactions that occurred during the Big Bang would have produced a different mix of elements, with much less deuterium-heavy hydrogen than is observed. So if you accept the Big Bang theory, there's no way out. The vast majority of the material content of the universe really is composed of mysterious non-baryonic particles. And then there's dark energy, a catchy name, but no one knows what it is. In 1998, astronomers discovered that the current expansion rate of the universe is larger than it was a few billion years ago. Apparently, the expansion of the universe is speeding up, despite the mutual gravitational attraction of galaxies that is expected to slow it down. Dark energy, which can be thought of as being like the repulsive force of empty space, is held responsible for this acceleration. So there you have it, the concordance model of cosmology. Some 70% of the full content of the universe consists of dark energy, the remaining 30% is matter. But only a small part of this matter, 4% of the total content of the universe, is composed of ordinary particles, and at most 1/4 of this baryonic matter, 1% of the grand total, is visible to us as stars and gas clouds. All of the jigsaw pieces appear to fit nicely. The only problem is that nobody knows what the puzzle represents. The makeup of the universe is astronomy's biggest mystery. If you enjoyed this video, please like and subscribe to the channel, and don't forget to watch other best videos that we made for you. Thank you.